this video, we're going to talk about equation solutions. We're going to discover how an equation can have one solution, no solutions, or infinitely many solutions. And I use this as the infinite symbol. I'm going to start with some simple examples of what a solution might be. Let's imagine that we've been tasked with expanding the road. We're a civil engineer, and currently we have a major highway that runs downtown with some buildings, and traffic has just become very congested. There's many cars on the road, and we've been tasked as a civil engineer for the city to expand these roads. Let's write down an equation. So maybe x here is the number of lanes that we'd like to add to each road, and x may vary depending on the area of the city that we're in. So let's say here in our downtown situation, x equals 2. Well, in that case, that's great because this equation only has one solution, and that is 2. And what we mean by solution is that what is the x that is going to allow our equation to be correct? And in our case, there's only one, and that's 2, because 2 plus 2 equals 4. And so that means that in our case, this equation has one solution. So now let's think about what it might mean for an equation to have no solutions as well as an infinite number of solutions. So in our last example, where our equation had one solution, was x plus 2 equals 4. In this example, our x was the number of lanes we wanted to add. Now I want to think of a different equation, and this is one that has no solution, but I'm going to switch around the variables a little bit. This time, I'm going to have x equal the number of lanes that we currently have. And let's say in this small town that in the suburban areas, there's only one lane of traffic going either way, and then in downtown there's 2 lanes. 2 lanes going one direction, 2 lanes going the other direction. And this 2 represents the number of lanes that we want to add. So similar to our x before. Now I'm going to add x on the right side also. It's going to be part of an expression, and this expression equals the number of lanes that we are able to add. And so the x equals the same thing, the number of lanes that we currently have, and this 1 is going to equal the number of lanes we're able to add. So you can imagine that these buildings here only allow a certain amount of space, and so that limits what this number can be. So in our case it's 1, and x plus 2 does not equal x plus 1. In fact, it never can equal x plus 1. There's no x that, when added to 2, will be the same thing as when that same number x is added to 1. So in this case, we say that there's no solution. A simple way to think about it is it's just a problem that doesn't have an answer. And finally, I want to go over the idea of what it means to have an infinite number of solutions. To do that, I'm going to clear out some of this other stuff here. Let's imagine a scenario where we want to add one lane, and again we'll keep x as being the number of current lanes. And this number 1 here is going to represent the number of lanes that we want to have based on our new traffic needs. Where this one is the number that we're able to add. So whatever our x is, these are always going to equal each other. It doesn't matter what x you put in, these expressions are going to be the same. We could think of it as, well, in downtown, our current number of lanes is 2. In the suburbs, it's 1. So our use case would be limited for this equation, but mathematically, you could put any x into this equation, and it will equal the same thing. If we can put in any value for our variable, but still maintain equality, we say that that equation has an infinite number of solutions.